Dear learners and viewers, this is our special series on virtual labs for self-paced and classroom teaching learning, and the topic that we are going to discuss today in this specific and special session is virtual lab as a learning tool. So what is virtual lab and how you can use it as a learning tool? You will be let us know by our expert. We have our expert in our studio with us. Let's meet them. You are Professor Sashi Prabha. You are Professor of Physics and Head of Planning and Research Division from CIT and CIT. Very warm welcome, ma'am. Namaskar.
Namaskar.
We have our another expert with us. Let's meet her too. You are Miss Anna Gupta. You are academic consultant from CIT and CIT. Namaskar and very warm welcome.
Namaskar, ma'am.
So what exactly virtual lab are, ma'am?
So, virtual labs are actually digital simulations of the activities that can be performed in real life situation that can be performed physically. So, one example is like EMF of a cell is 1.5 volt or 9 volt, whatever is there. So, in digital simulation it will appear as 1.5 volt or 9 volt. It cannot be shown abruptly at random number like 7, 8 something. So, the digital simulation of all those activity. Another example is that if the result of the experiment of a refractive index of a medium is 1.5, then it will appear as 1.5. It will not appear as random number 8, 9, 100, 200. So, it is digital simulation and at the same time it is interactive. And already it has been discussed, it provides lots of flexibility to the students, and students can learn at their own pace and at their own desired time.
At their own convenience.
Right.
Right. So, ma'am, how virtual labs can be used as a learning tool?
Yes, it is. What is the meaning of learning tool?
Right.
Learning tool, it facilitates learner to learn. Learner can manage their learning and also they can assess their learning. So, it provides opportunity for self-assessment also. If teachers are using, then teacher can also use as and when required assessment of the learning teaching situations, and in this way it enriches learning. And virtual lab develops various laboratory skills among students.
Right. So, ma'am, we are very excited to know about virtual lab as a learning tool. We would like to go towards our presentation as well. So, ma'am, can we make it full screen so that I can, our learner would came to know about all the things very easily?
Yes.
So, dear learners and viewers, feel free to connect to us. We are waiting for your feedback or your query. Please feel free to us and reach out to us through our various mediums. Yes, ma'am.
So, let us see how does it enrich learning. So, first of all we need to get convinced that virtual lab actually helps in learning and teaching. So, we see that virtual lab helps to observe and inquire about a particular process and phenomenon, and it keeps learner engaged as they are learning, and in this way it deepens learners learning and motivates them to share their experiences and help them to visualize otherwise invisible phenomenon. So, we can consider one example, like when salt is dissolved in water. So, what happens at the intermolecular level? We cannot we cannot observe, we cannot see directly the molecules, but with the help of the virtual lab we can see that how water molecule and salt molecule they are combining together, and in this way we can inquire that why it is interacting with this way, why the molecular attraction is taking place in this way, and then students get excited and they share their experiences of conceptual understanding. That is also very, very important in the process of learning. Yes.
Okay. So, this is how we can use it as a learning tool. And ma'am, how does virtual lab enrich learning?
So, obviously it enriches learning, like even atomic structure students can make nucleus by selecting proton, neutron, and they can observe that which nucleus is stable, which nucleus is unstable. They can make model of atomic structure. So in this way they can learn actually that how conceptual understanding processes. They learn a different from different example, and they can engage among themselves in a collaborative setup also. So we can discuss that laboratory is the central to the learning teaching of science. It has pivotal role in teaching learning of science. So obviously the physical laboratory has no substitute. The smell, the feel of the apparatus, and actually managing, manipulating, correcting, observing error of the apparatus have different feel, but virtual lab is one of the substitute, one of the alternative of actually physical lab. And this virtual lab can be used during process of learning teaching, or before pre-lab activity or post-lab activity, or directly with the help of virtual lab. It also teaching learning process can be continued.
Ma'am, this was quite an interesting to know about all the facts and information that you have just shared, and we would like to know about the science as a learning process, ma'am, as a process of learning.
Yes, science is a particular way of looking at nature. So how it is a process of learning. So we observe some phenomenon, some fact, some event, then we ask question, the why does it happen, then we make testable explanation, we make predictions, we make hypothesis. In making the hypothesis, we frame such question which can be tested, for example, what is the wavelength of the color used in this photograph, in this painting. So we cannot make question that why this color is looking more beautiful. So so testable question, testable explanation is important, and then we evaluate alternative explanation, and then we make connections with the existing knowledge. Now here two things are there. Existing knowledge means whatever teaching learning materials are available, text, net, encyclopedia, books. So what existing work has been done in this area, and also student can make connection with their own learning, and then evidences are collected. So in this process investigations are planned, experiments are performed, and then data are collected, and analysis of data is done, then conclusion is drawn, and then it is communicated. Communication in science means written communication, oral communication, digital communication in particular way, in a particular way, so that all can understand the given information. So graphical representation of the data is very important, and the calculation is to be done in such a way that anybody can replicate those experiments. And then the most important thing is that from the analysis of the question, from the search of your result, another question may arise. For example, if we are considering that solubility of water, which materials are soluble. So if we are taking salt, common salt, then other question might arise that why, how can we test solubility of sugar also, solubility of sand particle also, solubility of chalk powder also. So what is the quantity of water, what quantity of water can be taken so that it becomes saturated solution, what is saturated solution, what is unsaturated solution. So that way learning continues. So our lab provides all these situation.
Right, very well explained by you, ma'am, ki how we can use science as a process of learning. Now please explain to all our viewers and learners and give an example of virtual experiment in physics and how to perform and record our observations, ma'am.
Yes, I would like to present.
Dear learner, there will be a demonstration of physics very shortly, and if you have any query, we are receiving a lot of comments from you. We appreciate your efforts and please feel free to connect to us with your queries and questions. If you have any doubt regarding virtual lab, how you can perform and how you can observe your growth out there, please feel free to connect to us. You can call us on our telephone number, that is 8800 and 559, and let's quickly move towards our expert Shashi Prabha ma'am.
Yes, for virtual lab, CIT has made many learning teaching material, and with the collaboration of CDAC and Amrita, large number of virtual labs are available on Diksha portal. So, how to reach at Diksha portal? First of all, we see, so go to diksha.gov.in, then click at the fourth vertical, that is fourth dot from the right side, and you will get virtual lab. Then click at explore, and then click at the medium, then click at the subject and the class, and then subject. Now, let us see one virtual lab, how it can be performed. The experiment is to determine the resistance per centimeter of a given wire by plotting a graph of potential difference versus current, and hence to determine its resistivity. So, you can see here the one icon is for theory. The theory part of this experiment is given, that how Ohm's law is applicable here for the given wire, that I is proportional to V, or V upon I is equal to R. From this formula we can find out the resistance. Then for the resistivity, what formula can be used, that rho is equal to R into A divided by L, that is resistance of the given material, into area of cross section divided by length of the given material. Then we go to the procedure section. So, here also the text is given, that how to calculate, and observation table is also suggested. Now, let us see animation. So, from the animation we can see that apparatus are given here. So,
our aim is to determine the resistance per centimeter of a given wire by plotting a graph of potential difference versus current, and hence to determine its resistivity. To do the experiment, voltmeter, ammeter, measuring scale and resistance wire. Procedure: connect the positive terminal of a battery to the positive terminal of ammeter using a connecting wire. Connect the negative terminal of the ammeter to the positive terminal of the voltmeter using a connecting wire. The negative terminal of the voltmeter is connected to the upper terminal of the VO.
So, you can see that circuit diagram is also given, and with the help of the circuit diagram all suggestions are given, that how to make connections, which wire is to be connected from positive and negative, and then again we can see here
rheostat contact slowly,
and then
calculate the resistivity, specific resistance of the material of the wire. Resistance per centimeter of the given wire is 0.066 ohms per centimeter, and resistivity of the material of.
Now, let us see one other icon here, simulator. So, how does simulator work? So, apparatus are provided here. So, here one icon you can see help. So, we can go through the help, how to proceed. So, show circuit diagram. I am clicking at a circuit diagram. Let us select the material. that we want to use for determination of resistivity. So, say I have chosen silver, then what length of wire you are planning to take. So, I have taken 10 centimeter. What is the diameter of the wire? So, 0.2 diameter of the wire we have taken 0.46 millimeter, and then resistance of the rheostat, which rheostat we have chosen. So, we have taken 100 ohm rheostat. So, you can see that the choice of the specification of the apparatus are given. Now we can proceed. Here we can see the wire is given. So, let us connect this wire, click at the terminal, it gets connected, and then click it here, and if there is wrong connection it will not go, it will not get clicked. For suppose I am making a wrong correction, so it will not work. So,
Okay.
so students can learn from their mistake that this is not correct circuit diagram.
At that very moment they came to know that.
Yes, at the very moment, because you can see that here is rheostat is being used as potential divider. So, one upper terminal, one lower terminal. So, let us try to do wrong connection. So, I am doing here, this is correct. Now, if I will make any, if I will connect it to the upper terminal, it will not work.
Okay.
So, now let us put down the key. So, key is put down here, connect the resistance wire. So, I have not connected the resistance wire.
So, it won't work.
It would not work.
Okay.
So, suggestions are given. Now, where to connect the resistance wire? So, the voltmeter will be connected across the unknown resistance. So, I have connected here. Now, say I am connecting it here. Now, it has been connected. So, it will not function. If I will connect it wrongly, it will not function, it will show. Now, I am connecting, switching on the plug. So, taking out the plug, now I have completed the circuit. Okay. So, now we can take our measurement. Look here. So, after making connections, after making circuit diagram, it is not like circuit is completed and my work is done. Now, each student can make their own observation. So, observation tables are provided. So, what is the value of voltage here? So, voltage value it is given 0.012. So, let me fill it 0.012. And what is the value of current? So, let us read it 0.208, 0.208. So, here automatically resistance is calculated.
Okay.
So, in the same way we can increase the value of voltage, say let us change the value of voltage, and then we can keep on taking the reading. So, show result. So, in this way resistivity of the wire is calculated, it is 1.59 into 10 raised to the power minus 8 ohm meter. But in order to perform the experiment fully, we need to take 5 observation and then take mean of all the values, and then we draw the graph. So, let us see the other thing here. You see the video also, and then from the graph,
require different amounts of
we calculate the resistance, and then there is a spherometer, then there is a screw gauge. With the help of that we can measure diameter of the wire, and then we can put all the variables in the formula, rho is equal to Ra by L, and then we can calculate resistivity. So, so it is in this way all student can perform experiment hardly within 15-20 minutes, and even teacher can monitor, and in between the assessment question can be asked, like why do we connect voltmeter in across the resistance, why don't we connect voltmeter in series or ammeter in parallel. or other questions. So, is it, what is the direction of current, what is conventional direction of current, and what is the reason that the resistivity of one material is more and one material is less, does it depend upon the temperature also. So, other question may be asked by the students.
So that would be a great help for all the students, right?
Yes, yes, that will. And then in this portal we can see that there is video is also given. So
Of current. Find the most efficient way to get the proper current. Ohm's law is used. Ohm's law was. We are
So I am
determining the
proceeding fast
resistivity
here.
of a given resistance wire. The voltmeter are working properly. Measure
So,
the diameter of the wire
screw
using
gauge-
the screw
the
of
screw gauge-
unknown resistance. It's an amplifiers, oscillators, power generators, etc. It is also used to figure out the correct
So, what are the application of this concept, because that also our learners want to know, why should we study this. So,
Right.
what are the applications? So, this Ohm's law and resistance of the wire, knowledge of this is very, very important in our everyday life. Like we know that we want material of higher resistance if we want to use a water heater, but we want to use material of very low resistance if we are using stereo set or speaker, so that quality of sound is maintained. So, how can we select those material? So, all these things can be used. Even in computer also we choose material having particular value of resistivity.
Right, and very beautifully explained by you, ma'am. Could you please demonstrate another example or experiment of other subjects?
Yes, let us see. Is it working? Yes. We are going to learn one example of fraction, because laboratory work is important in all the subjects. It is not only in physics, chemistry and bio. In maths also laboratory work can be helpful.
So, ma'am, we can get graphs as well.
We can get graph also. Just so let us see one example of English language. So, I am going to OLab and I am clicking at language and going for English, and let us see how can we learn preposition. So, the site is made very pedagogically sound, because for the learning teaching, if we explore the existing idea of the student, what are the common misunderstanding, common mistake they make. So, we can start from here. This is the common mistake students make, that I am in the bus or on the bus. So, which one is correct to use? So, let us see with the help of lab how it can be used. So, I am clicking at exercise 1. Yes. Now, let us make it. So, first of all we have to click at the instruction. I am clicking, I am ready, and then it will start. That means it will not start suddenly if you are ready to understand what is to be done. So, what is to be done here? Let us see. See the question and drag instruction. Okay. So, place the ball between the family portrait and the clock. So, family portrait is here and this is the position. So, congratulations, your answer is correct.
Okay.
So, we get immediate feedback. Now, put the ball on the chair. So, I am putting it on the table. Let us see what happens. This is not the correct position. Currently, the ball is on the table. So, I will do it again. So, that means if learners are given immediate feedback, then learning deepens because they can understand by doing, and they can understand by observing also. Now the next is put the ball on the chair. So I have done on the chair, then it is correct. So one feedback will be there, and then next question. So this way we can continue learning, and all the questions can be done here. So if the ball is kept on the chair or below the chair, so your answer is correct. Now see the next question. So the instructions are given. So in all these virtual lab, Viva VOC, that is also given for the assessment.
Okay.
So in this way, the assessment can be integrated with the learning teaching of the subject in all the virtual lab, in science also, in English also, and Hindi virtual labs are also available, Sanskrit virtual lab are also available, maths lab is also available, and everywhere assessment is given. So this is like integrating learning, teaching, assessment and technology. These
Right.
are seamlessly woven with the material.
Right. So there are plenty of options, right? They
Plenty.
can watch the video, they can perform the activity, they can do voice mem as well.
Yes, they can observe other things also. So let me present one like one CIT has made many augmented reality material also. So augmented reality material can also be used as a virtual lab.
9 point.
Like augmented reality, I think our listeners are aware that mobile lab is available, that is PME Vidya AR app, and when the app is placed over the figure of the textbook, then you can observe 3D video here. So in the mobile there is control of the learner, they can switch, but this is 3D video. So you let us see one presentation on the action and reaction.
Forces are equal and opposite. Learning objective: to conduct an activity to observe the effect of Newton's third law of motion using a combination of the two spring balances. Click on the continue button to continue. Click on the spring balance B to hang it over the hook.
Oh,
Figure 9.10. Using a combination of the two spring balances. Click on the spring balance B to hang it over the hook. The free end of spring balance B.
I am moving it fast so that we can observe many other also. So the connection, the instructions are given on the mobile app, and student can
Drag the slider to make the combination. Drag the slider to apply the force on the spring balance A. Stop it at different points and observe the readings of spring balances A and B. B to be equal is observed that both the spring balances show the same readings on their scales. Click on the continue button to continue. Why do both the spring balances show equal readings on the scale? Click on the continue button to continue. The force exerted by spring balances A on B or B on A are equal and opposite. This is because these forces form a pair of action and reaction forces, and the wall exerts an equal and opposite reaction force on spring balance B. Click on the continue button to continue. Simultaneously and on two different objects. Click on the continue button to continue. Learning outcomes. We can plan and conduct investigation to observe the effect of Newton's third law of motion. We can measure force acting on a body using a spring balance. We can draw conclusion that for every action there is equal and opposite reaction. Moreover, action and reaction forces act on two different bodies.
So we can see that if it is virtual lab experimental work, then any one of the variable can be controlled, and a study of those independent variable is observed. So in this way these experiments, these activity can be performed by students themselves, and it has been found that learners become very happy when they observe that every time how action is equal to reaction, and also they can understand that action and reaction occurs simultaneously and they act on two different bodies. So this is also very important concept. They learn this thing by doing activity, doing experiment.
So that was very beautifully explained by you, ma'am, and you have just shown us two different demonstration and experiment from two different subjects. One was from science and one was from English. Now we would like to know about the other subject as well. Ma'am, Anna ma'am, we would come to you and we would like to know about more maths subject. So do we have labs available for mathematics subjects as well?
Yes, we also available for mathematics. So now I am going to show you one simulation for mathematics. So I am taking one example of mathematics simulation, and this is the topic from the class 8th. So my topic is algebraic identity. As we all know that algebraic identity exists only when the values of both the right hand side and the left hand sides are same. So first we will continue. Okay. So firstly we have to select the medium and the class. Okay, class. Okay. My screen is okay. Again I am taking select the state, and now I am selecting the district. Okay, so now we have one maths lab activity, that is verify the algebraic identity, that is a plus b whole square is equals to a square plus 2ab plus b square. As we all know that we have four basic identities, but today I am explaining the most important property, that is a plus b whole square is equals to a square plus b square plus 2ab. So with the help of this activity we can also derive numerous other activities. So firstly we will click on this activity, verifying the algebraic identity. So on the first page we have a theory which is based on the algebraic identity. So what is algebraic identity and what we are going to explain in algebraic identity, all the explanations are there, and we also have previous knowledge attachments. For previous knowledge we know that what is the square and what is the area of the rectangle, so such areas we all needed in simulation. So we have an animation which is related to the topic. In animation we have a video which is related to the simulation, and now I am performing the simulator that we are actually performing, how we can identify that both the sides of the identities are same. For this we have a learning outcome, and student will able to, in the learning outcome student will be able to expand or factorize the algebraic identity, and the student will be able to calculate the square of a number by expressing it as the sum of two convenient numbers. So now we will start the activity. So objective is to verify that. So let us verify that. So what we are going to learn in this activity, some instructions are also there. We are going to practically verify the activity with the help of the areas of squares and rectangles. And initially, firstly we will take the values of a and b on both the sides to create the two squares with area a square and b square, and we also create some rectangles with the area AB and BA. So we will try these shapes into the area, that is a plus b whole square, and we will verify the formula. So we have a screen. So for the firstly we have instructions in the below, and in the below we have instruction that click on the tools button and select the square. So we will click on tools button and we have a square. So we will click on square, and what dimensions we have to take for these two squares, all the range are given. So side of the square ABCD, that is in A units, we can take from the values 10 to 15. So I am taking value 10 units for the first square, and for the next square that is PQRS in B units, the range we have to take again 10 to 15. So I am taking value 12. So now we will click on draw button. So now we have two squares with the side A units and with the side B units, and we can see that the square ABCD with the side A units having area A square, and the side and the square PQRS with the side B units area has B square. So now we have another instruction that click on the tools button and select the rectangle. So again we will click on tool button, and now we have rectangle. So we will click on rectangle, and in this first rectangle we have length A units and the breadth B units, so that we can say that the area of this rectangle will be AB. And for the next now click on the tools button and select the rectangle. Again we will click on another rectangle. So we have a rectangle with different units, and now we have a length B units which is different from other rectangle, and the breadth is A units, and again we have the same area which is in the terms of BA. So now click on the next button and observe all the shapes together. So we can observe that we have four shapes here. First shape is the area of the square, and the second first shape is the area of the square, that name is ABCD, and the second one is the area of the square PQRS, and third is the area of rectangle EFGH, and fourth one is the area of rectangle LMNO. So as we can see that in the first square we have A units, so we can say that area of the first square is A square. And what is the area of the square PQRS who's having B units? So we can click on B square. And what is the area of the rectangle EFGH? As A units as its length and B is as its breadth, so it will be length. As we all know that area of rectangle is length into breadth, so it will be A into B, that is AB. And the fourth one, the area of rectangle LMNO. Now we have a length B units and breadth is A units. So now we have a area length into breadth, that is B into A, which is BA. So here we have four figures, and now we are combining these two all these four figures in one square whose area will be A plus B whole square. So click or select the appropriate answer from the drop down and click on the next button. So I am clicking on this. So now I have to fit all these four values in this one big square whose side is A plus B. If its side is A plus B, it means that its area will be A plus B whole square. So what we are observing in this activity, we are observing that all these four shapes are fitted in one box whose area is A plus B whole square. So we can contribute that key A plus B whole square is equivalent to A square. So we are fixing one of the square first, and next square is B square, and third one is the shape of rectangle. So I am fitting in this. So all the four figures are fitting in one square box whose area is A plus B whole square. So from this we can conclude that the A plus B whole square may be equals to A square plus B square plus AB plus BA. So now we will click on the next button. What will we observe? Observations are also there. So conclusion is what? Conclusion says that the area of this big square AIGE is equivalent to area of square ABCD plus area of square CHGF plus area of rectangle DCFE and the area of rectangle BIHC. So all the areas we have already find it whose areas are a square plus b square plus ab plus ba. So we can combine ab plus ba, which is equal to 2ab. So the combined area is a square plus 2ab plus b square. So that's why we can say that this a plus b whole square is equivalent to a square plus b square plus 2ab. So from both the equations we can write this identity: a plus b whole square is equals to a square plus 2ab plus b square. So now we will click on the next button to verify mathematically. We can verify mathematically by putting the values of a and b in different forms, and if I am writing the value 4. So now here my value of a is 4 and the value of b I can put it as 6. So what is 4 plus 6 whole square? In the left hand side, 4 plus 6 whole square, that is 10, 10 square is 100, and when we put same values in right hand side, that is a square plus 2ab plus b square, so we will get the answer 100. So left hand side is equals to the right hand side, so therefore we can say that a plus b whole square is equals to a plus b, a square plus 2ab plus b square. So this is the simulation that we can perform the activity, and we also have options. Self-evaluation questions are also there in mathematics, and in self-evaluation question teacher can assess the student how will they understand the topic and how much they understand, and if a is equals to 6 and b equals to 7, student can put the answer and give their feedback. And there are also reference questions, reference books are also there. We have two options are there, and in the last one we have feedback. So with the help of this
electrolysis
so we all know that
of water. Learning objective.
So we all know that in maths lab student can understand the concept and verify the mathematical facts through the activity. So we can say that it will act as a tool for increasing learning efficiency.
Thank you so very much, Anna ma'am, for your demonstration on mathematics. It's actually quite interesting to know how you can solve your mathematics problem on virtual lab. It's quite interesting, and we are running very short of time, but still Sashi ma'am, we would like to know more about biology. Could you please demonstrate an experiment of biology, ma'am?
First of all, I will show something about chemistry, that is electrolysis of water.
Okay.
Look here. So I will open.
Continue. We have taken a plastic mug containing 2 holes at its base. Click
I will go fast.
Could we
on the
have,
continue
Yes.
arc.
can we have that video on screen, please?
Click on the battery to connect it with the carbon electrodes through
I
wire.
will request from my technical team to have that
Click
video
on the
screen,
highlighted
please.
beaker to fill the mug with the water till the electrodes are immersed. Dilute sulfuric acid into the mug containing water. Sulfate ions. Click on.
So in this experiment, let us check that how can we verify that hydrogen gas is emitted here. So I will move here fast.
Hydrogen ions are attracted to the cathode and gain electrons to form hydrogen gas. However, of water, reduction reaction at the cathode and oxidation at both electrode due. Correct answer. Reason.
Now in this learning teaching material, assessment is given in between, so that the student can move towards right path of learning, right conceptual understanding. So let us move now fast again.
Yields 2 molecules of hydrogen. Drag the burning candle to the mouth of the highlighted test tube. Caution: this step must be performed carefully by the teacher in the laboratory. Observations. Hydrogen. Burning splint of the candle ignites the hydrogen gas. Oxygen. Burning splint of the candle relights with the oxygen gas. Click on the continue button. Electrolysis of water produces hydrogen.
So, we can see that here learning outcomes are also given, so that it will help students to do self assessment, self learning. What was the purpose of learning? Because many times it happens that students perform the activity, but they are not able to understand that what concept did they learn and on what point they need to give focus. So, it is also self learning material, audio and video is there. Now, I would
Here, let me tell you that we have only 4 more minutes left for the session, ma'am.
okay. So, this is one open resource also. So, how
Other than Diksha.
other than Diksha. So, this is a Java applet. It is how we can correct our error, this myopic and nearsightedness and farsightedness. So, do we need to use concave lens or do we need to use convex lens? So, you can see that if we use a wrong lens, then what happens? So, we cannot observe the distant object properly. So, we need to bring here concave lens, and then we see that the rays are focused at the wall of the retina. So, similarly other is that structure of ear, it is given in class 8th teaching learning. So, you can listen here. So, the audible range is 20 hertz to 2000 hertz. So, how pitch varies, what happens when frequency is varied. So, and also different part of the ear can be studied with the help of this, and one open resource is there that can be used for thematic teaching learning, that is available as in FET, on the FET website. So, we can see that based on the concept of light, using this virtual lab only, we can understand, we can perform experiment using spherical lenses, using prism, and we can also do assessment that what is the refractive index of the unknown material, given material. We can take measurement. So, just 1 minute here, the source is like when it is moved, then what happens? Let us see, total internal reflection can also be taught here, and at the normal what happens? This is the process of refraction. So, let us click at the tool and let us bring it here to measure the angle, because measurement of angle is also a skill that students should learn. So, is it 60 degree or is it 90 degree? So, students can do it here. And similarly, if I am using a prism, say I will choose prism and I will bring prism here, and then let us see how refraction takes place. So, here we can show refraction takes place, then we can bring a spherical lens here.
Right.
So, it means that some thematic based, theme based concept virtual labs are available as open resources, and this can be used right from you can say that class 3, 4, 5 up to 12th standard it can be done, and depending upon their learning needs, even the wavelength of light can be regulated.
And how can teachers integrate virtual lab with the classroom learning teaching, ma'am? In a brief, we would like to know.
Yes, it is a very good question. That is, integration is very, very important. So, let us see here, please show the screen. Say we have to study about correction of nearsightedness and farsightedness. So, this is a textbook example given. So, it is important to learn to draw the diagram also, but at the same time just now we observe that when concave lens is used, then nearsightedness is corrected, or convex lens is used. So, if students they learn by doing, by selecting the lens themselves, it can be very, very helpful. So, for teachers can just map those concepts which are available as virtual lab. Actually, what virtual lab, all the materials are available. So mapping and when to use in learning teaching process, so some planning is required on the part of the teacher.
Of course, indeed, some plannings are required, and as you just said, all the materials are there available on virtual lab, right, ma'am?
Yes, and even help of the students can be taken to search for those material and do mapping. So students can also do these things.
So they can do by themselves.
But they can search those virtual lab, and then teacher can then review whether it is okay and how to use it, how to integrate in teaching learning. That is when to do observation, when to do recording, when to do explanation, when to address alternative concept, when to do assessment. All these things then teacher can plan.
Of course, all those things a teacher can plan, but here right now we are running very short of time. We cannot proceed this session further, but let me wrap up this session here only. But before that, let me thank our experts. Thank you so very much, Prabha ma'am and Sashi Prabha ma'am and Anna ma'am for being with us.
Thank you so much.
And for your detailed information on virtual lab as a learning tool. It's indeed very informative session. Thank you so very much, ma'am.
Thank you. Thank you.